Let's take a look at another example of hypothesis testing with two samples. In Wichita, a sample of 73 male carriers showed that 10 had been bitten by an animal during 1 week. In Philadelphia, a sample of 80 male carriers showed that 16 received animal bites. At a 5% significance level, which is another way of saying alpha equals 0.05, is there a significant difference in the proportions? So again, we'll introduce what our subscripts will represent. So I'll have mu sub w is going to be, actually, in this case, we don't need mu. We're going to call this, say, p sub w is going to be the proportion of Wichita bitten. And we will do p sub h to represent the proportion of Philly bitten. Okay, now notice real quick, I did not use mu's because we're not using means, so mu sub 0 will never appear, but I will be having proportions appear. So we will take a look at our hypotheses. Our null hypothesis says that there is no difference between these two proportions. So p sub w is going to be equal to p sub h. And then the alternative, we're saying, is there a significant difference? So is p sub w not equal to p sub h? So here what we see is that we have two samples, we have proportions, and this is a two-tailed test. But once we know that it's two samples to proportion, then we're going to use a two-proportion z-test. Because remember, proportions, those form a normal distribution, so that's why they're z's. So if we turn on our calculator, we go over to stat, we go right over to tests, we go down to a two-prop z-test, press enter. Now we enter in our data. Remember, x, these x's that we have, these are going to correspond to the number of whatever in that category. So we're looking at the number of people who have been bitten. So x1 is 10, n1 is 73 because there's 73 total, x2 is 16 because there's 16 received bites, 80 total. The alternative hypothesis says that they're not equal, and now I calculate this. So what I find is I find that my test statistic is going to be equal to z is negative 1.04 and my p-value is equal to 0.3. So what this now says is that this doesn't really seem like there's not that much of a difference. If you look over on the calculator here, you should see that you have the p-hat and the p-hat. These two samples, the first sample had roughly 13.7%, the other one had roughly 20%. That does not seem like it's going to be that much of a difference between the two of those. So if we go now over to finish off this problem here, we compare this to alpha. So since the p-value is equal to 0.3, which is definitely larger than 0.05, which is my alpha, we do not reject the null hypothesis. There is not sufficient evidence to believe there is a difference. So we're looking at the two proportions. There does not seem to be enough evidence to show that there is a statistical significant difference. It's not just due to random chance that we happen to have different proportions. So that concludes that question.